So, welcome everyone. Thanks for your prompt responses to my initial email. As we've agreed, I will try to send some guidance materials through, probably in this form, so that they will be short instructional videos that I'm going to post to YouTube and to send a link. Apologies also for not being quite punctual with the release of these. I'd hoped to have had it done ready for the start of a Monday class time, but couldn't because some of my neighbours decided that, yes, they really had to have outdoor work done for several days, and that's been too noisy to be able to then make good use of sound without it driving whoever's watching and listening pretty crazy, I think. So, yes, welcome to Let's Do the Show Right Here Productions, and I'll send two videos first of all. The first one I'd like to just complete a few comments on Morris 1993, and then I'll send through a separate video working through, say, for the first 8 pages of Hasty. So what I'd like to do first of all then is open up on page 226 of Morris. So that's page 226. And I think at the end of the last class session, we were dealing with this material, but Tanya had to leave early. So if we take a look at example 27, he talks about the way that Tenney and Polanski generated what looked like a usable COM matrix, but was actually, they thought, indicative of an impossible melodic sequence. In other words, a C-seg that you might draw up from this COM matrix would not itself be internally consistent. So Tanya, just to let you know and to refresh for Charles and Yi, if we look at that COM matrix, it seems to be well formed. If we though go to row 1, which you'll remember is the time dimension, whereas vertically is the spatial dimension of the relative position of units, they could be pitches. If we model row 1, which is 0, then lower, then higher, we could give those values of 1, 0, and 2, and that would seem to be fine. We could go to row 2 and think of a C-seg for that. So the middle position now is occupied by 0. The first element that would be higher than it, hence it has a plus. The next element would be lower than it, hence it has a minus. So if we gave those the numerical values 2, 1, 0, that would be fine. For row 3, you'll notice that the position finder now in time terms has moved to the bottom corner of the little square grid. And that says that relative to the final element, one element, the first element is lower and the second element is higher. So we could model that as 0, 2, 1. So each of the temporal sequences would be correct. The problem is, the reason that they're impossible is quite easy to see. They should be generating the same C-seg, the same sequence. And what they do, in actual fact, is generate 3 different C-segs. Morris, however, thinks that it is possible to resolve this. And he said the reason it's impossible is because it's incomplete. It's incomplete in the sense that the final step in each of the rows should have 2 elements in it. In other words, 2 elements that occur at the same time, one of which is higher than the other, so he gives it a plus, and one of which is lower, hence he gives it a minus. So he says, actually, what you can show is that each of 4 particular versions of this COM matrix will generate coherent C-segs. The first one does, 2, 1, 0, and 3 occur at the same time. And then the middle of our 3, that was 2, 1, 0, is mapped showing the encircled sequences. So if you look at the very top, 2, 1, and 0, the 0 will be the 2, then lower would be the 1, and then lower again would be the 0. So that checks out. If we look at our 1, 0, 2, that's modelled in the next grid. So for instance, we have 0, which would be 1, then lower, and then circled is higher. So in other words, there's always a missing element and it's the encircled pictures that show us how to read this sequence. Now the impossible contour, he says, actually looks like this. So that would be our 0, 2, 1. So we took a look at the top line. 0 would be equivalent to 0, which is lower than 2 and then lower than 1. If we move to the middle position, so our 0 is now 2, 2 is higher and hence a plus, and also higher than 1, hence a plus. What's frustrating is you'll see that on the bottom row, he picks out a minus and a plus, which is inverted. He does not say why this inversion occurs, so it makes it quite difficult to read. However, I think we still can read our 0, 2, 1 if 1 is the position that we take upon the extreme bottom corner of the impossible contour grid, and assume again that one element is missing. 1 would be higher, hence the circle around the first plus, but also then lower than the 2. So you can model it, but what you have to assume is that 2 elements occur together, only one of them is picked out for each of these C-segs. He says, actually, this is a mathematical phenomenon. That phenomenon is a category he calls Stirling numbers. And he says these are well known in mathematical theory. But let's go on now just to consider what is the musical consequence for contour for that. And he says, really, that's my example 28. So that appears on page 227. He calls these general contour types. He says there are 7 in total. For us now, it's useful to concentrate on column 6. So take a look at column 6. If we look at column 6 in the vertical sense, that is the x-axis, it's modelling, let's say, pitch. If we look at it in terms of left to right, that is the y-axis, it is modelling time. So that what he's showing is, for instance, at least 2 units in terms of either pitch or time. Sometimes 3 in terms of, say, pitch element or musical unit, and then the time points that they occur in. He then goes on to talk about the way that time then creates its own kind of counter logic to the C-seg sequence. In other words, if we sort of try to map time onto space, although you can model it, and there are 7 basic forms, and those are the ones that he shows, you also may find that you get into counterintuitive contexts when you insist on certain features in terms of time occurrence. So this is now example 29 on page 228. So he gives us 2 musical units, which as he says, even though these are abstract, you can see that they are technically retrogrades. There is a prime and then there is a retrograde. And there is 1 unit, the 0 and the 2, that occurs at the same time point. But he said if we apply an algorithmic condition, which is remove the first pitch in a repetition, actually what we'll generate is 2 separate C-segs. In other words, the reduction will not form a clear retrograde. So you can see that in the 2 silhouettes that he produces. The first is not the direct retrograde of the second, because we've taken out the first of the repeated pitches. Now, I wish he had been more explicit as to why he'd impose that condition. He does not say. He does not say it's because, like we've talked about before, repetition means that you need at least 3 elements to confirm significance in music. In other words, first element, can't interpret it, nothing to relate it to. Second element could still be a coincidence. Third element is the one that establishes pattern. Okay, first one, nothing to relate it to. Second one actually confirms something but could still be a coincidence. We hear 2, so high-pitched sounds, we're not sure whether that's a cell phone ring actually happening. And then the third one tells us, yes, it definitely is. So I wish he'd been clear as to why he takes away the first temporal occurrence, but he doesn't. He doesn't give us any extra clarity. What he does do is talk about the way in which if this sort of temporal criterion is imposed as a sort of separate overlayering, although we've seen things happening in time, now if we actually impose that in terms of reduction, it's actually going to mean that the C-seg classes become more complex to track. He says, he uses the phrase, it would dull Occam's razor, because we would generate, if we take out retrogrades, for instance, and just have inversions, no retrograde inversions either, then the class kinds that we would have would greatly increase. So he says this is rather sort of counterintuitive and perhaps not very streamlined, but nonetheless it tells us musically how complex we're sort of are bound to think in terms of sound processing. So he says perhaps then we have to deal with the idea that contour theory can only work with monophonic context. In other words, really, it's a melodic phenomenon. It looks as though it could actually sort of offer something in terms of simultaneities, in terms of chordal occurrences, but perhaps we can't model it satisfactorily because we don't have a way of showing how space and time, apart from, say, some very limited cases, which are very basic but logically constructible, can actually be generalized. Okay, I hope you got something from this. My second video will actually include some questions. So I'm going to move to Hasty. I'm going to hopefully also provide you with a link to a YouTube version of the piece which Hasty is concentrating on. That's Stravinsky's Symphonies of Winds. This version from YouTube also includes a score, and it's a recording which I think is a pretty good one. It's not released within this decade, but it is a good one, a good conductor. So I'll talk more about that the second time, and I'll also embed the questions. I'll try to speak slowly, but I'll embed the questions, and then if you could respond to the questions in brief email answers, hopefully that will be useful to you. It will give a bit of feedback to show that you're actually engaging for me, and we can continue working from there. So I hope you find this useful. I'm almost at 12 minutes, so I hope I'm not sort of run up a massive total of megabytes for YouTube to cope with. So I'm going to stop recording now, and you'll see me again in my second video. Okay, thanks again. Bye-bye.